All right, this is the second video in section 4.4. You know, in 4.4 we've been talking about trigonometric functions of any angle. And last time we were talking about angles in any quadrant. In fact, we started out with one in the second quadrant, right? And we said this was theta, and this had coordinates 3, 4, or negative 3, 4, or whatever, you know, just whatever the coordinates would be. Negative 3, 4. And we use that then to find the ratios of any function. We drew a right triangle in here, and we called this negative 3 and this 4, and we know that that's 5, and we wrote all the trig functions. And what we assumed on most of these was that theta was an acute angle. An acute angle. All right, but sometimes, I mean, well, like even when you look at this example, theta is not acute. Theta is obtuse. So what we said was that we could use a triangle. We could, whatever theta was, we could set up a right triangle. And then we could use that right triangle to write the ratios of all the trig functions based on this angle right here, this theta angle. So what we were using and what we didn't identify in the last video and the last lesson was that while this is theta right here, theta was not inside the right triangle. The angle inside the right triangle is acute, not obtuse. So that's what we're going to talk about today. We're going to talk about this angle that's inside the triangle that's called a reference angle. So we're going to define and identify reference angles, and then we're going to use those reference angles to find values using the unit circle. And this is to find values for angles that are acute, obtuse. Angles that are in the third quadrant are going to be bigger than obtuse. In the fourth quadrant, those angles are going to be even bigger. And that's what we're going to do in this lesson. Okay, so we have a coordinate plane, right? And we're going to draw in an angle. And this angle is going to be in the third quadrant. So this right here is theta. But theta is not an acute angle. In other words, it's not in the first quadrant. So if I have an angle in the first quadrant, right, this theta is going to be acute. It's not acute. This one is not only not obtuse, it is bigger than obtuse. So what we're going to make use of in this situation are what we call reference angles. And reference angles are acute angles. Reference angles are acute angles. And they're always drawn to the x-axis. So for instance, this one right here in the first quadrant, theta is a reference angle in the first quadrant. Okay? The next rule is not only are they acute, but they are drawn to the x-axis, not the y. Always the x-axis. So here, from here to here is theta. It's also the reference angle theta prime in the first quadrant. All right, so now when we're over here in the third quadrant, do you see that there is an acute angle here made by the x-axis and the terminal side of theta? Okay, it's not the same measure, but it is a reference angle. It's an acute angle. So if I draw that in, right here, this angle right here, just this one, is theta prime. That's the reference angle. And if I draw it in the fourth quadrant, right, an angle in the fourth quadrant looks like this. But the reference angle, this is theta, The reference angle is this one, theta prime. Okay, so why is that important? Well, if I have an acute angle, then I can actually use that angle and the unit circle to find the values off the unit circle. So here's a recap of what we've learned so far. We've said that for every angle drawn in standard position, any angle that you draw, first quadrant, second quadrant, third quadrant, fourth quadrant, there is another angle called a reference angle. Now, note the exception. What angles do not have reference angles? Well, that would be quadrantal angles, ones that are on the axis. Okay? A reference angle is the positive acute angle formed by the terminal side of the angle and the x-axis, not the y. Reference angles may appear in all four quadrants. Although in the first quadrant, it says here, I am my own reference angle, right? Acute. And so that's what it says there. So you can see here that if in this one, the terminal side of 120 degrees ends up in the second quadrant, then the acute reference angle is going to be this 60-degree angle right here. Okay? In the third quadrant, 240 degrees, its reference angle is 60 degrees, or pi over 3. In the fourth quadrant, look here, this is 315 degrees. The reference angle is not drawn to the y, or over here to this quadrant, stays in the quadrant of the terminating side on the x-axis. Okay, so I have written here, this is a 300 degree angle. Theta is 300 degrees. Okay, the reference angle, if this is 300 all to here, is 60 degrees or pi over 3. All right, this angle right here, theta, is pi over 4. It's 45 degrees, pi over 4. All right, since it's in the first quadrant, the reference angle is also pi over 4. Okay, here I have theta, which is 7 pi over 6. 7 pi over 6 is in the third quadrant. The reference angle will be this angle right here, which would be 7 pi over 6 minus 6 pi over 6, which leaves pi over 6. So the reference angle, or theta prime, is going to be pi over 6. Okay, and this last one, this fourth one, this angle right here, is 7 pi over 8. It's not on the unit circle. 7 pi over 8. All right, so what would the reference angle be? Well, the reference angle would be this angle right here that's almost too small to draw on. So you would take pi minus 7 pi over 8, and that would leave you pi over 8. So this reference angle, theta prime, is pi over 8. Okay, reference angles. Why do we need them? Well, reference angles are the acute version of the obtuse angles, or bigger angles, like we said before. And it's helpful when you need to know the value of a trig function for angles not in the first quadrant. Because basically you use the reference angle to find the value, and then you change the sign according to whatever quadrant it's in. So for instance, if I have theta is equal to 120 degrees, right? And I want to find the reference angle. So I graph it. I know it's in the second quadrant. This is 120 degrees. And then I want to find the reference angle. Well, this right here is the reference angle. So it's 180 minus 120, so it's 60 degrees. Okay? So now, if I want to find the cosine of 120 degrees, I can determine the sine, cosine is negative, and I can find the cosine of 60 degrees, which is 1/2, and put a negative in front of it. And that helps me find the trig function. Okay, so I found the reference angle, I sketched them both, and I use degrees. So let's do another one where I have radians. So I have, let's say, 7 pi over 4. 7 pi over 4. So I'm going to graph that. 7 pi over 4 is in the fourth quadrant. Goes like this. So this in the red is 7 pi over 4. This right here, this angle drawn to the reference angle is, drawn to the x-axis is the reference angle, and that is pi over 4. So if I want the sine of 7 pi over 4, then I find the sine of the reference angle, pi over 4, which is square root of 2 over 2. And then I look in the fourth quadrant where sine is negative. So the sine of 7 pi over 4 is negative square root of 2 over 2. Now, I think we've been using reference angles intuitively when we did the unit circle. And so this should not be a huge concept for you. You should be able to understand it, I think. We're going to use these reference angles to find the trig functions of sine, cosine, and tangent without a calculator. And we'll be doing that with degrees and radians, but we're going to be switching over to radians pretty soon and using mostly radians and not degrees. So be sure that you've memorized your unit circle.